The Turpan Karezes in Xinjiang, China represent a remarkable achievement in traditional irrigation, reflecting a profound adaptation to the region's arid conditions. Densely distributed across Turpan, a pivotal hub on the ancient Silk Road, the Karezes have their origins traced back to the late Ming Dynasty. This region, known as the heat pole of China, contends with high temperatures, scant rainfall, and intense evaporation. In response to these challenging conditions, the inhabitants of Turpan have skillfully exploited the natural terrain to develop an intricate groundwater management system. The Karezes are ingeniously laid out to align with the gradients of alluvial fans, where they either run parallel or diagonally intersect the direction of the subterranean water flow. This network comprises vertical shafts, subterranean tunnels, open canals, and water storage ponds, each component playing a crucial role in water extraction and management. The vertical shafts are particularly critical. They connect the surface to the underground tunnels and facilitate both the construction and process and the removal of excavated material. A typical Karez features numerous shafts, ranging from a few to several hundred. The first and deepest, known as the mother shaft, is usually sited on the gentle mountain slopes, with depths varying from tens to over 120 meters. As the water moves downstream through the tunnels, the shafts become shallower until the water emerges into surface canals. The distance between these shafts decreases from 60 to 100 meters upstream to 10 to 30 meters downstream. The excavated soil forms sand dunes around the shafts, reminiscent of pearls strung along a necklace, a testament to the enduring ingenuity and labor of the Turpan people. The subterranean tunnels of the Turpan Karezes are intricately divided into two main sections: water collection and water delivery. The water collection sections lie below the local water table, while the delivery sections are above it. Gravity plays a crucial role in transporting water through these gently sloping tunnels, guiding it from the collection points to the exits. The length of these tunnels varies significantly, ranging from 3 to 5 kilometers, with some extending beyond 10 kilometers, depending on the depth of the water table and the terrain's gradient. The canal between the outlet, where water flows out of the subterranean tunnel, and the water storage pond is called the open canal. Downstream the water outlet, irrigation is achieved through gravity. Water storage ponds are also essential components of the Karez system, used to regulate and store irrigation water. Most Karezes, except those with minimal water flow, are equipped with these ponds. Larger Karezes may even feature multiple ponds to manage the water supply effectively. Once the water exits the storage ponds, it is then channeled to irrigate farmland and provide water for local villages. Throughout human history, the Turpan Karez system stands out as a prime example of ingenious design and construction. The process starts with locating upstream water sources, estimating the depth of the water table, and calculating the optimal gradient for the subterranean tunnel based on the soil characteristics. Excavation begins downstream by digging the open canal and water outlet, or longkou, followed by the construction of the subterranean tunnel and vertical shafts. Building the tunnel is the most challenging and time-consuming part of the project, with the workers relying on oil lamps hanging in the vertical shafts for illumination and guidance. Completing a single Karez often required the dedication of several generations. The challenges on hard soil, cramped working spaces, and the biting cold of Tian Shan Mountain snowmelt made the task even more arduous. To ensure survival and transform the desert into an oasis, the forefathers of Turpan painstakingly dug over 1,200 Karezes, creating a vast network of underground tunnels stretching over 3,200 kilometers. This remarkable feat required immense investments of human, material, and financial resources. The Karez system is celebrated not only for its innovative engineering structure and construction techniques, but also for its profound historical, agricultural, ecological, engineering, and cultural value. Nearly 190 Karezes remain operational today, nurturing local communities and irrigating nearly 6,700 hectares of farmland. The Karezes also contribute significantly to cultural tourism, attracting over 20 million visitors annually to explore this marvel of sustainable engineering. The Turpan Karezes epitomize the harmonious relationship between humans and nature. Known as the lifeline of China's heat pole, this ingenious network underpins the enduring spirit of Karezes, characterized by diligence, wisdom, courage, unity, and the relentless pursuit of excellence.